Okay, welcome back. We're on video 2 of the character controller. So I update it to the new Unity and then realized that Bolt didn't work with it. So I saw that they finally released an update. So the Bolt beta, Bolt 2 does not work with this, but at least the stable version of Bolt, let's see what version it's called. Bolt 1.4_11 F2. So that works. That works with this new version. So what we did last time was we just had simple movement. So what we're going to add is changing the direction of the character in the way he's moving. So he'll look right or left based on whether he's moving left or right. And then we'll start with a very simple jump, and then we'll move from there. I'm just removing some stuff I realized I added when I was testing some things out, and this video failed, so I had to redo it. Okay, so let's start with Bolt. So grab your Bolt. You'll see we've done all this usual code here. Straight after this, we're going to do the rotation. So how do we do that? We're going to drag out and type in quaternion dot look rotation, and we're just looking for the one with the forward in the brackets. So quaternion look rotation forward. Okay, so what this is going to do is it's going to take whatever value you put in and give you an angle for that. So it's not just necessarily for movement. You could use this for pretty much anything. So you could say, look at that object, get the object's position, and then feed that into the rotation so that the object, your turret, could look at that object. So you can use the look rotation. So it's going to give you a rotational value or a quaternion based on a vector 3, as you can see on where it says x forward. It's x, y, and z. So we're going to drag that out and make a new vector 3, because all I care about at this moment is the x movement, which is just, if you look at my character, it's my side-to-side movement. So this is the way character is moving. So all I care about is the input that I have for the x. If I were to go up a ladder, I would have to add input for the y, that sort of thing. So right now, all I care about is the x movement, and we have that in the variables of our graph. We remember we created a player input variable which controls it gets the horizontal inputs, your A and D key, your arrow keys, and your left analog stick, and it saves it into this variable called player input. So I'm just going to plug it directly into there. Okay, so as it is, it's not going to work. So I'm leaving y and 0. Y and z is 0 because there's no inputs coming for that, so that value can stay as 0. So I don't mess around with those rotations. So all we're doing here is we're getting that rotational value. So now we need to actually apply it to the object that we're rotating, which in this case is the character. So we're going to drag out, we're going to type in transform.rotation, and we're looking for set. So transform.rotation set. We want to set the player's rotation based on the value, this rotational value we're getting from the input that the player is giving us. Okay, so that'll do it. So I'm going to hold down Control, just add a little group around here. Call this rotate player in direction of movement. So rotate player in direction of movement. That's all that's going to do. So we can test that, but right now, if you what I did in the previous video, so I'm not going to do it again, but I'll show you what I did. I just added a cube to the front so I can see if the character is actually rotating. And if you ever wonder what the front of your character is, select your character and look at where the Z is pointing, which is the blue arrow. The direction that the blue arrow is pointing is where the character is looking. That's his forward. The red arrow, the X, is his left and right movement. And then the Y is obviously his up and down movement. So let's test if this is working. The red one is the Bolt guy, so the red one should be rotating. There we go. He's now rotating in the direction that he needs to go, which is really good. Now notice when I release the button, the character's rotation goes back to 0 because the input over here, if you look at the bottom here, is 0. So if you look in the top right here where the Y rotation is being affected by my input, it's either -90 or 90, and then if I release it, it goes back to 0 because that's the value that's being fed into that. Okay, so there are two ways to fix this. Actually, there's two things we can fix with one solution. I don't really want to be adding velocity to my character if he's standing still. It makes no sense. He's not moving. Why am I using all these calculations to add velocity to a static object, an object that isn't moving? So I'm going to move my fixed update across here, and I'm just going to add a branch or an if statement. I'm going to ask first of all if my character is actually moving. If he's moving, or if I'm getting any input. If I'm getting input, then just, let's do all of that stuff. But if not, let's just ignore it. Let's not spend a lot of time calculating the rotation, calculating the velocity for a character that isn't moving. It's pointless. It's really... So whenever you put anything in the update or the fixed update, really consider if it needs to be there. And if it needs to be there, it's a really good way to manage it with if statements so that things only happen when they have to happen. Okay, so we're going to check our player input. So I'm going to grab our player input. I'm going to see if it is not equal. I'm going to plug the not equal into the branch. And what is it? If it's not equal to 0, so from the B, drag out and make it a float literal. So if it's not equal to 0, that means the character has to be moving. That means either the D key or the A key is being pressed, which will give us a value of 1 or negative 1. So it's no longer standing still. So we're just going to put a comment group around here and say check for player input, because that's what I want to do. I want to make sure that we have player input before we do all of this other stuff, so we can actually test that out now. We're gonna look at this here. Notice how it will, when I start the game, it's going to be firing this line, never passes the branch until I press the D key, and you'll see that it was pulsating through the true or the A key. DA, and you'll see when I stop, it stops. Now the character no longer stops, rotates back to 0, because it only remembers the last active rotation that it had after the branch. Because once I release, the branch stops firing, which means the character stops rotating back to its 0 position. There we go. So the character is now rotating in the direction it needs to rotate. There we go. So that's good. So we're going to do the exact same thing. We're going to go to the C# guy and do the same thing. We're going to grab our little C#, open up our script that we created in the last class. I went back to Visual Studio Code, got it working. If you guys enjoy using Visual Studio Code because of the speed at which it opens and the way what I would do with it to get it working, if you're getting an error, like if you're getting mono behavior errors and everything is pretty much broken, just go back to Unity, go to Assets and say Open C# project, and that'll resolve that issue. Don't know why it did it recently with the more recent versions, but that is what's happening. Okay, so what do we need? We need to make sure that in the fixed update, we're going to add an if statement. I'm going to move this line, using Control Shift up arrows, just to move it up and down a line. And what are we checking for? If player input is true, is not equal to 0. There we go. So exclamation equals is not equal, and if equal means if it's equal to something. So just keep in mind. So I'm checking to see if the player's input is not equal to 0, like we did in the bolt. I'm going to add that velocity and that movement. So all we need to do is add a new line here. We're going to go and we want to set the rotation, remember, so we went transform.rotation is equal. And what was it equal to? We remember we created a new vector 3, and all we did was plug something into the actual, sorry, I'm jumping ahead of myself. Let me delete this. We have to go and type in quaternion dot look rotation. So first we need to calculate the look rotation, and the look rotation requires us to have a vector 3. So that's where I'm going to go, new vector 3, and all I care about is the player input for the X, comma 0 for the Y, comma 0 for the Z, because I don't care about those rotations, not at the moment. Whoops. Okay, so that'll now allow the character to rotate in the direction and only update movement when the player is actually moving. Just let the script recompile, push play, and let's test this out now. So now both characters are looking in the direction they're moving. There we go. So that's it. That's the movement setup, pretty much complete. We're going to come back to this and replace it with an actual model and then add a few lines of code for the animator, that sort of thing. But for now, the base movement is in place and working, which now leads us, let me go to my flow graph here, to do our jump. So I'm just going to put a comment group around this entire section here. And let's just call this player movement, just so we know that that controls the player movement. And then down here, we're going to go and add an on button input. So what this means, it's like a get button down, get button up, or get button, equivalent to code. So on button down, what is the button? Jump. I'm using actions that Unity have by default. If you don't know where I'm getting this name from, go to edit at the top, go down to project settings, go to input, and you'll see that it's over here. So we've got jump here. That's how you spell it there. And then it's using the space bar key or the space key. And the other jump, which is down here, also called the jump, uses the joystick button 3. So those two are the, and what's nice about this is you never have to go and change that name and code. You just need to add another jump if you need another input. So add another input action and assign the key that you want, as opposed to saying get key down or key codes. Once you start hard coding things in whether it be Bolt or C#, you have to keep going back into those scripts and changing those things. And why would you want to do that when you can just use jump as your action? So you probably have noticed we're not using the new input system yet. The reason for this is I'm trying to keep with something that works both in Bolt and C# at the moment. Once Bolt supports the new input system, and once the new input system has got a full release, then I'll just update how to use the new input system, which is a lot more robust and powerful. I'll show you how to do that. But for the time being, we're going old school here. We're using the old input systems. So we're saying when we press the jump button, what we want to do, we want to go and say rigid body dot add force, if I could spell force, and we're looking for force comma mode in the brackets. So force comma mode, because we want to change how the force is behaving. So your standard force is it adds constant force while it's being fired. So it will also have a gradual, it will have an ease in curve. So it will start slow and speed up, and it considers the mass of the object. The next one is acceleration, which is exactly the same thing as force. So it'll speed up over time, and then once it gets to terminal velocity, if you will, it will keep that constant speed. But it will not consider the mass of the object. And then we have impulse, which is instantaneous. So the moment I add that force, if the object was at 0 velocity, within a frame it will have whatever velocity you apply happening instantaneously. And then the last one is exactly the same as impulse, velocity change, but this time it doesn't consider the mass of the object. So we have two that do two of them do the exact same thing. One considers the mass of the object and the other one doesn't for both instances. So we're going to use impulse because I want to take into consideration the mass of the object, and I want it to be an instant thing. We're kind of making a platformer kind of game, so I want whatever movement I do for the jump to happen the moment I do it. So I'm going to drag out the new force and create a new vector 3. Actually, I do not need to do that. I don't know what I was thinking. We need to actually go to the object variable tab, the variables object tab, sorry, and let's add a jump force. That's going to be a float, and by default I think I'm going to set it to 10. And we're going to add another one which we're going to use, let's leave it for now like this, and then we're going to add a boolean called grounded, because we need to know whether or not we are grounded in order to jump again. So we have a jump force and a grounded boolean, which I'm going to set on to be true by default. Okay, so what are we going to do? We're going to right click and type in vector3.up, because that's the direction I want to jump, so vector3.up, and we're going to multiply that by the jump force. Now if you're wondering why I'm not multiplying this by time.delta time, is essentially it's adding this force once when I hit the button. So I'm not calculating force this isn't being updated every single frame, so I'm just adding this force once and then letting gravity take over after that. So I'm not too worried whether I use time.delta time or not. I haven't found any weird results, so I'm okay. I'm happy with not using time.delta time here. But if you feel you want to be safe, you can go ahead and add that. That really should make very little difference, other than the fact that you're going to have to up the jump force value in order to get a better, like a higher jump. Okay, so let's test this. So I'm going to show you that it works, but it's going to be broken because I want you to understand how we're going to fix it. So there we go. I can pretty much jump in as many times as I want, so I can pretty much create a Flappy Bird if I wanted to. This is how you would create a Flappy Bird. There we go. So we need to limit this. First things first, we're going to make a very basic jump, and then in the next video we're going to talk about how do we add double jumps, how do we add what I call a variable height jump. So a jump that can, if you tap the button, he'll jump, have a smaller jump. If you hold the button, he'll have a higher jump. So, but first we need to get the standard jump working, and then we can build on top of that. So we're going to go back into the flow graph, and I'm going to add a branch. And this is going to be checking for this variable we created called grounded. We're going to drag the grounded variable in, and we're going to plug it in there. So as long as the character is grounded, then we will be able to jump. If it's not grounded, then we're not going to be able to jump, and we shouldn't be able to jump unless we have a second if statement checking to see if the character can double jump. So let's just call this group jump. Okay, there we go. Now all we need to do is do a ground check. Now there are so many tutorials out there that use sphere casts, ray casts, all that kind of stuff, and those are all great. So I just want to show you another alternative to doing that. It's not better or worse, but in this case I think it's going to be a little bit easier to understand, and you can get consistent results with this as well. So I'm going to select my bolt guy, go into 2D mode so I can just see it in an orthographic flat view. And I'm going to add a sphere collider. There it is. And this is going to calculate whether or not we've touched the ground. So I'm going to make it, you can make it as big or as small as you want. So if you want to say, okay, this is my character from side to side, I just want to make it maybe a little bit small, like 0.45 or something. Maybe 0.4 should be good. And then I don't want him to touch the ground that far away, which is basically, we're looking at a radius, so which means he's going to be almost half a meter off the ground when he can jump again. So I'm just going to up this a little bit to like 0.3, so that now it's only sticking out for like 10 centimeters at the bottom of my character, just so that and I don't want this to actually collide with the ground, so I don't want the character to kind of like, why is my character above the ground? Why? So I'm going to set this collider to be is trigger, because all I want to know is if this object overlaps another one or not. So that's what we're going to do there. So we're setting it to is trigger, and I just want to use this for both the bolt and the C#. So I'm going to right click on that sphere collider and say copy component. I'm going to go to my C# one, select any of the other components and right click on them at the top there and say paste component as new. So there we go, and now you'll see both of them have the same collider in the same location. So that's good to go. So let's go back to our bolt guy. We'll finish his jump completely and we'll go do the same thing in code. So how do we set this grounded to be true or false? We're just going to use a on trigger enter for when you hit the ground. And I'm going to add another one called on trigger exit to see that if he's left the ground. So on trigger enter, on trigger exit. For those of you making 2D games or 3D games, remember if you're making a 2D game, just use a rigid body 2D and use your 2D colliders, and instead of an on trigger enter, use a on trigger enter 2D. There we go, like that. So just whichever one, whether you're making a 2D game or 3D game, just use the relevant physics engine to do this, and then you should be fine. Okay, so on trigger enter, I'm going to hold down Alt and drag in this grounded variable to set it. So it's now a set variable. And I'm going to set this to a bool literal. And when we're on the ground, it should be true, like that. And then I'm going to duplicate those two nodes by going Control D, plug it into the onTrigger exit, and those should be false. So when we hit the ground, we should say we're grounded, and when we leave the ground, we should say it's false. I'm going to add a comment group around there, call this ground check. It's going to make sure this makes sense and it's clean and tidy. Okay, so that's pretty much your default basic jump. It's physically accurate. It's going to work every time. So if you select your bolt character and open up the variables, you'll see that I'm currently grounded. If I jump, notice how the boolean went to false. When I hit the ground, it's true. So I can keep spamming this button as much as I want while I'm in the air. The only time I'll jump again is once I've actually hit the ground. There we go. And that is how you pretty much do your jump. We're going to add to this because I know it's physically accurate, but thanks to games and thanks to everything we've seen online and animations and stuff, we kind of accelerate the jump on the way down just to make it feel better. So we're going to add a gravity multiplier, which is just going to, as the character's dropping down, we're going to add a little bit more. We're going to just take the physical gravity of the physics engine and multiply it by a value so we can just make it stronger or weaker, the gravity itself. But we'll keep the jump for this video just as your standard basic jump, which means you jump once, and when you touch the ground, you're able to jump again. So let's do the exact same thing in code. So I'm going to open up my script, and in here we need to add two variables like we did before. So first I'm going to add a serialized field for my jump force, which is going to be set to 10 by default. If you probably noticed, I did not actually give it a variable type. There we go. And the next one's going to be private bool, and this one's going to be grounded, and I'm going to set that to true by default as my default setting. There we go. So let's get this guy jumping, shall we? Now you could do it in the fixed update, but I find that doing the jump in the fixed update or the update really doesn't really make a difference. So I'm just going to say we'll keep it in the update. We can switch it around and see what happens if you want to take a look at it. So what are we listening for in this if statement? If input dot get button down, 2 round brackets and quotation marks because we're referring to a string. We're calling this action jump. Remember we did the same thing at bolt. We're looking for the spacebar button, but I'm also looking for and if we are grounded. So I'm checking to see if we've pressed the spacebar button and if we're on the ground when it happens. If so, we're going to go rb.add force, 2 round brackets again, and in the round brackets it requires what direction are we adding force and what type of force. So the direction is going to be like we did, a vector3.up multiplied by jump force, comma, force mode, dot, and we used impulse. So you can see we got the exact same thing in C#, acceleration, force, impulse, and velocity change. So I'm just going to add my standard impulse, and that is your jump. So that's going to work, but now we need to do our ground checks. So let's just add some comments in here. So this one here, we're going to 2 forward slashes, we're going to say player movement there, and over here we're going to put a comment after this called update player rotation in direction of movement. So that's what we're doing there, and this one simply just does cheapers. This one is add player velocity in input direction. Okay, and then up here, that's simple enough. This one here is store player input into variable. That's all we're doing there. And down here, if we want to be very specific, here we're saying jump system. There we go. So now we have all our comments, and down here we can just add, between the last two curly braces, we can add an on trigger enter. We can call this one ground check. And then we just want to add the other one, so on trigger exit. Oops, let's try that again. I don't know how. I must have downloaded an extra extension that has two different on trigger enters and exits, and one adds a lot of awesome information, but still it's a lot there. So this is our ground check. On trigger enter, on trigger exit. What did we do in Bolt? We said, remember, we went grounded is equal to true if we touch the ground. On trigger enter, and then this one was grounded is equal to false if we're no longer, if the collider exits the ground. So that's it. That is our ground check. This little system here, as basic as it is our ground check. So let's compile that. Let's save it. You'll notice now we have a new variable here called jump force, so we can control that directly from the editor. There we go. I can spam both of them, and they will only jump, and they'll be identical because the logic and the code and the engine that it's running in is identical. The results will be identical. Okay, so reminder of variables. Player speed controls how fast the character moves. Jump force controls how high the character's jump is. So then that's it for this video. So thank you so much. I hope this has been helpful. Next video we're going to just go further into our jump and tweak how we're going to control the jump height, how we're going to control how many jumps we want to have, just so we can make this a little bit more of a robust system. Something like if you were making an Ori or you're making a Hollow Knight and you just have, like, you somewhere like an hour into the game you get a double jump or you get an air dash, that kind of thing. So we're going to develop this further. So thank you so much. I hope to see you in the next video. Cheers, guys.